This video I'm going to pick up talking about pain receptors. Previous video I was talking about touch and how we have three different main kind of groups of receptors. We've got pressure receptors, we've got temperature receptors, and then we've got pain receptors. And so we're going to be talking here about pain receptors. There are lots of reasons why pain receptors might come online. One, I talked about in the previous video, is if you exceed the temperature of warm temperature receptors. These pain receptors are present in most areas of your body, but not the brain. I know that sounds weird, but you don't have any pain receptors in your brain tissue. Pretty much everywhere else in your body, you are going to have pain receptors. We most often think about pain receptors being in your skin, but you do have them in your muscles. You're familiar with that. If you've damaged a muscle, pulled a muscle, put something out of place. You also have pain receptors tied to things like your organs. So these are spread out throughout your body. You have different concentrations of them, just like we have different concentrations of them for the touch and the temperature based on what they're being used for. Most of these are what we call high threshold receptors. So they're only going to respond to intense stimulation. Small amounts of stimulation, so small pokes and so forth, are not going to create a firing of your pain sensor receptors. Think about like if you get, we talked the pressure receptors, if you get poked with like a pen, it doesn't hurt. You can feel it, you can see it, but it doesn't trigger pain. And that's because that would be considered low threshold. Versus if you get stabbed, I'm not going to show you that one, but if you get stabbed with that pen, that is going to be intense mechanical stimulation. That is going to fire these receptors because that's going to pass that low threshold into the high threshold and stimulate these pain receptors. So these will go into action if you have enough pressure in the case of mechanical, thermal. So if the temperature is high enough, so you go past those warm receptors, the temperature receptors, so you go above that 113 degrees Fahrenheit, or chemical stimulation, meaning that you have exposed the skin to some sort of chemical that is doing damage to your skin or other organ, whatever it might be. So intensity and location, that is going to make the big difference. So like I said, intensity, poking, small poke versus a stab is going to make a big difference. And the location, because some areas are going to have pain receptors that are slightly lower thresholds than others. Think about, there are areas on your body where the same injury is going to hurt a lot more than if you did it somewhere else. Again, most of the time, if you do things on your hands or on your toes, it's going to hurt more and create more pain than if you did it, say, on your arm, the same sort of injury. And that's because these pain receptors on, in your hands and in your feet are going to fire at a slowly lower threshold, and you usually have a few more of these pain receptors in those areas. Now, the interesting thing about pain receptors, which we don't see as much with pressure or temperature receptors, is that pain receptors actually become sensitized to prolonged exposure. So what do I mean by this? So after an injury, it's going to take less to trigger them to start firing again. So it's going to take less of a reaction of some sort to get them to fire. Think about it. After you've gotten a cut, a deep bruise, whatever it might be, if you touch, bump, whatever that area, that same day, later in the day, the next day, a week from then, if it's not healed up, it can just be the slightest touch or brush, and though that area is going to hurt again. And this is what I mean by it becomes sensitized to prolonged exposure. So after that injury, it's going to take less damage to trigger those pain sensors than it did before. Let's see. Oh, the other chemical one. So you can expose yourself to chemicals, but the other one, I was just glancing at some of my notes. Poison from insect stings. So if you get stung by a bee, stung or bit by something like a red fire ant, those can fire off. And if you've been stung by either of those recently, those hurt. And that's because those chemicals trigger these pain sensors in your skin. All right, so the next thing that's tied to these pain receptors is a concept that we call referred pain. So what is referred pain? This is a visceral pain that's felt in a somatic area. So just hang with me for a second. So visceral pain, visceral is your guts. So this is some sort of pain that's happening internally. So it's tied to your heart, your lungs, your intestines, your gallbladder, some sort of internal organ system. But you don't feel it on that internal part. It's felt in a somatic part. Somatic means surface or skin. And so you can feel it in skin or you can feel it in muscle. And so that's what we mean by referred pain, because referred means it's kind of being referred, or it's a referral from the visceral to the somatic. It's being transferred from one region of the body to another. And a great example of this, you've probably heard, one of the symptoms of a heart attack is that you get pain in your left shoulder, arm, or armpit. And that is a classic symptom of a heart attack. Same sort of thing, gallbladders. Gallbladders are interesting. I actually had this issue. Gallbladder is located up under your liver, but you can have pains all up under your rib cage and across to your side. Basically, pains in any area except for about where the gallbladder is. And what this is, it's caused by misinterpreted firing of neurons. So your brain can't really tell you, hey, it's your heart that hurts. But it can tell you, hey, something in this area hurts. Or sometimes it's just that the neurons get crossed on their signals, and so the firing goes down the wrong direction. And so that's why it ends up telling you, instead of the pain being in the heart, the pain is over here in your shoulder, even though that's not where the signals are coming from. And so the signal is coming from your heart, but the kind of wiring gets crossed on the way to the brain. And so by the time it makes it to your brain is thinking that that signal came from that shoulder area and not from the internal organ, in that case, like your heart. So referred pain is where you have a pain coming from an internal organ, but the pain appears or feels like it's in another region on the surface. So these pain receptors are incredibly helpful because they do help us from basically doing more damage to ourselves. Because, for example, a big part of it is the sensitization. So after we sensitize them after damage, we're less likely to damage that area again anytime soon because it takes so little to fire off the pain receptors in that area again. We tend to leave it alone until it heals. And they do have high thresholds, so think about temperature, but they also fire fairly quickly. So if you've ever touched like a hot pan or something like that, you generally tend not to touch these things or expose yourself to this intense mechanical or thermal or chemical stimulation, if you can help it, for very long, because those pain sensors tell you, hey, stop. And then you, if you can, are going to stop because they are going to fire and fire fast.